Today we will see the problem 8.2 of Griffiths third edition Introduction to Quantum Mechanics. I have already uploaded the lecture on this topic, but here I have used a different technique which is easier than the previous one. The problem is find the best bound on the ground state energy for a one-dimensional harmonic oscillator using a trial wave function of the form psi of x is equal to a divided by x squared plus b squared, where a is the normalization constant and a and b. Here a is the normalization constant and b is the adjustable parameter. So first we have to find the normalization constant. So we know that the integral psi star psi, here is psi star trial wave function, psi star psi. If you are integrating it, you will get 1. Here trial wave function is a divided by x squared plus b squared. So if you change the limit from minus infinite to 0, then that multiplication factor 2 will come here, and then modulus a squared 1 over x squared plus b squared whole squared dx. Now you make a trigonometry substitution. Let this x is equal to p tan theta. Then what is Tx? Tx is equal to P secant squared theta T theta. So now you replace it here. This will become T theta, Tx will become P squared secant squared theta T theta. And here this x squared will become P squared tan squared theta plus p squared, but I am taking p squared outside. This will become p power 4 tan squared theta plus 1 whole squared. Tan squared theta plus 1 is secant squared theta. So this and this will get cancelled. Remember that there is another whole square. This is secant squared theta of square. So naturally this will become simply secant squared theta. And this p will get cancelled with this p power 4 will become p power 3. So this will become 2 modulus a squared over pq between the limit. Now we have to change the limit. When x is equal to 0, this will happen. Sin theta, tan theta is nothing but sin theta over cos theta. When x is equal to 0, that is sin 0, 0. So lower limit is 0. Then what about the upper limit? See, sin theta over cos theta. Tan theta is sin theta over cos theta. So when theta is pi by 2, this cos theta will become 0. So this will go to infinite. So we are changing the limit from 0 to pi by 2. So 0 to pi by 2. And here in the denominator you have 1 over secant squared theta, which must be equal to 1. Now we got this integral. The 1 over secant squared theta is cos squared theta t theta. This can be. This is the standard integral. The value of this integral is pi by 4. So I have written here pi by 4. And 2 a modulus a squared divided by pq is outside the integral. So I have taken that. Now you can cancel this 2 with this 4, which will become 2. So in modulus a squared pi divided by 2 pq is equal to 1. Or modulus a squared is, you bring this to the right hand side, 2pq over pi. then what is A? Just to take square root of this thing. So PQ can be written as P multiplied by square root of P. So that's what I have done here. A is equal to P square root of 2P over pi. Now we will move on to the next. In order to find the total energy, we have to find the expectation value of the kinetic energy and the expectation value of the potential energy. By definition, the expectation value of the kinetic energy is equal to integral psi star, then the kinetic energy operator P squared over 2m psi we got to find. So here the trial wave function is modulus a squared. You know, modulus a squared value is 2pq over pi, and psi star is 1 over x squared plus p squared. Already we have taken the normalization, square of the normalization constant outside. Then the kinetic energy operator is minus h cross squared over 2m T2 over Tx2. So you have to differentiate this twice, that is second order derivative. If you take the second order derivative, then it is very simple and straightforward. You will get 8x cube divided by x squared plus p squared power 3 minus 2 divided by x squared plus p squared whole square. So now what I am going to do is, here it's square, here it is cube. I want to make the denominator as a common, x squared plus p squared power 3. Then naturally I have to multiply this by x squared plus p squared. Now you can see here you have 8x squared and this 2x squared. 2x squared will get cancelled with this 8x squared because it's a 90 sign. So you will get 6x squared minus 2p squared. So you got this in the numerator and denominator is like this. Now you can take 2 as a common fact. Then this will become 3 in the numerator, 3x squared minus p squared, of course divided by the denominator x squared plus p squared whole power 3. Now you replace this value, this second order derivative. So here and also you can cancel some of the term here. 2 will get cancelled and you will get minus h cross squared pq divided by m pi divided by m pi, and this integral I am replacing this second order derivative by 2 3x squared minus p squared over x squared plus p squared whole power 3, and I am integrating over x. So now we will move on further. So now we got this integral, that is expectation value of t is equal to this one. Here this is a second order derivative of the trial wave function. This is a second order derivative. So naturally we can take this 2 outside this integral. Then remaining thing is in the numerator you will get 3x squared minus p squared. I want to cancel this x squared in order to make my integration simple one. So what I am going to do is I am subtracting and adding 3p squared. Then you can group this 3x squared plus 3p squared. So I can take 3 as common, x squared plus p squared. So remaining thing is minus p squared minus 3p squared will become minus 4p squared. This I can divide into 2 integral. Then one more thing is here minus infinite. I will change this integral limit to 0, minus integral to 0. So naturally one multiplicative factor will come. So 2 into 2 I am taking outside 4. So this is 3 times and one x squared plus p squared will cancel out this denominator. So this will become x squared plus p squared whole power 3, and I am taking this 3 outside. Change of integral will be taken care of this multiplicative factor 2. So 2 into 2, 4 you will get. Then next integration is minus p square, 4p squared I am taking outside, and 0 to infinite 1 over x squared plus p squared x power 4. So I am taking this as one integral. This is I1, and the other one is I2. This is I2. We are going to find the value of I1 and I2. Now the integral I1 is 3 into this integral 0 to infinite 1 over x squared plus p squared whole power 3. If we integrate this by substitution method, that is as usual, you take x is equal to uh, p tan theta. Then tx is equal to p secant square theta t theta. So you replace tx by p secant square theta t theta, and x squared will be p squared tan square theta plus p squared. I am taking this p squared outside, so already there is a whole power cube. So p squared will become, if you take outside, this is p power 6 tan squared theta plus 1 whole power 3. So now this p and p power 6 will get cancelled, and it will become p power 5. So I am taking this 3 divided by p power 5 outside, and here tan squared theta plus 1 is secant squared theta power 3. So in the denominator, if you cancel this both, you will get secant squared theta whole squared. So this is secant power 4 theta, which can be written as cos power 4 theta t theta between the limit 0 to pi by 2. Then how this changes to 0 to pi by 2, I have already explained. When theta tan pi by 2 is infinite, because it's sin theta by cos theta. So then now this is the standard integral, that is integral between 0 to pi by 2 cos power n theta t theta is equal to, here you can see in the numerator you have n minus 1 multiplied by n minus 3 and n minus 5, it will go on up to 1. So similarly in the denominator it is n. This is subtracting add integer. In the denominator you are subtracting the from even integer, that is n minus 2, n minus 4, it will go up to 2. Here this will be applicable when n is equal to even number. Here n is even, n is 4, so even, so naturally this will be your result. So naturally I1 will be, you take the multiplication factor outside this integral, 3 divided by p power 5, then n minus 1, n is 4, 4 minus 1 is 3, n is equal to 4, 3 by 4, and what about second term, n minus 3, this is n minus 3 is 1, and n minus 2 is 2. So then you will get pi by 2. Here this 3 into 3 is 9, and this pi will come as pi, and here in the denominator you have 4 into 2, 8 into 2, 16. So this will be 9 pi divided by 16 p power 5. And now we have to find the integral I2. which is equal to 4p squared integral between 0 to infinite 1 over x squared plus p squared power 4 tx. Use the same procedure followed earlier, that is x is equal to p tan theta. So naturally Tx will be P secant square theta T theta, and this will become, you take P square outside, so this will become already whole power 4, so this will become P power 8 tan square theta plus 1 whole power 4. So now you can change some of the term, this P and p squared pq, so will get cancelled with this p power 8, which will become p power 5. So you bring this p power 5 outside the integral, this will become 4 divided by p power 5, then integral 0 to pi by 2, then this secant squared theta tan squared theta plus 1 whole power 4. Tan squared theta plus 1 is secant squared theta, so this will become secant squared theta power 4. So secant squared theta will get cancelled with this secant squared theta. This will become secant squared theta power 3. So which is secant power 6 theta t theta between the limit 0 to 5 by 2. Here outside integral you have 4 divided by a power 5. So cos power 6 theta t theta you apply this. See, this is also even. So for even number, integral 0 to pi by 2 is cos power n theta t theta is n minus 1, n minus 3, n minus 5, it will go up to half. That is, in the denominator it is n minus 2, n minus 4, up to 2 it will go. So first this is 6. 6 minus 1 is 5, and 6 5 divided by 6, and this 6 minus 3 3 n minus 2, that is 6 minus 2 is 4, and the n minus 5 is 1, and n minus 4 is 2, and it is pi by 2 we got. So now we can cancel some of these terms. This 4 and this 4 will get cancelled, and this 3 will get cancelled with this 6, which will become 2. So in the numerator you have 5 times pi, and in the denominator 2 into 2 into 2, 8 into p power 5. So this is the I2. Already we have find the value of I1. Now we will find the expectation value of the kinetic energy. Now we got this integral, which is a constant parameter multiplied by these two integral. We have seen the value for the first integral, including this multiplier, is equal to 9 pi divided by 16 p power 5. Then this one, the second 4 multiplied by this integral is equal to 5 times 5 divided by 8p power 5. So now you can cancel some of the term. You have p power 3, which will get cancelled with this p power 5, which will become p squared. I can take p squared as common. Then remaining thing is you have 4 h cross squared, minus 4 h cross squared divided by this pi, and pi also will get cancelled, this pi. So you will get minus 4 h cross squared divided by mp squared. Here you have you take 16 as LCM, which will become 9 minus 10. So this 9 minus 10 is minus 1 divided by 16. So this minus and minus will become plus, and this 4 will get cancelled with this 16 will become 4. So you will get h cross squared 4mp squared. So this is the kinetic energy term. Now we have to find the potential energy. By definition, the potential energy of the harmonic oscillator is of m omega squared multiplied by the expectation value of x squared. So the expectation value of x squared is modulus square of the normalization constant, which is 2p power 3 divided by pi, and this integral between minus infinite to plus infinite, uh, x squared divided by x squared plus p squared whole power whole squared dx. Here also you follow the same technique. You replace x as p tan theta. Exactly same procedure. So this will become this x squared will become p squared tan squared theta, and tx is will become p secant squared theta t theta, and this you will get if you take p squared outside, it will become p power 4 tan squared theta plus p squared power whole square. So now we have to simplify. Here remember that x squared we have replaced by p squared tan theta squared. Now we will simplify this further. Now we got the expectation value of x squared. We have to integrate this one. So here you can cancel some of the terms. Here p is squared into p power 3, so which will get cancelled with this p power 4 will become p, and this p will get cancelled with this p cube, so this will become simply p square. This limit I have already explained how this limit comes. So 4p squared over pi, and this integral tan squared theta divided by 1 plus tan squared theta is secant squared theta whole squared. So 1 secant squared theta will get cancelled. So here is this secant squared theta will get cancelled with this 1 plus tan squared theta, and only you have secant squared theta here. Now this will become tan squared theta divided by secant squared theta t theta. What is tan squared theta is sin squared theta divided by cos squared theta, and 1 over secant squared theta is equal to cos squared theta. So this cos squared and this cos squared will get cancelled. That is, then naturally you will get only sin squared theta. Outside multiplication factor is 4p squared divided by pi. So now you have to integrate this sin squared theta t theta. So which can be written as 1 over 2. So that 2 will get cancelled with this 4. You will get only 2p squared over pi 1 plus cos 2 theta t theta. Now if you integrate cos theta, you will get sin theta. So lower limit sin 0 0, for upper limit sin 2 theta. Remember that this is 2 theta. Sin pi by 2 will become sin pi. So in both cases, for both upper limit and lower limit, this cos, if you integrate this cos 2 theta, it will become 0. Only term left is t theta. T theta, if you differentiate, you will get theta. For upper limit pi by 2 minus 0. So it is simply pi by 2. Here this pi will get cancelled. This 2 will get cancelled. So naturally the expectation value of x squared will become p squared. So naturally the expectation value of potential energy is of m omega squared, expectation value of x squared, which is p squared. So of m omega squared p squared you will get. Now the expectation value of Hamiltonian is sum of the expectation value of kinetic energy and potential energy. Expectation value of kinetic energy is, we have seen 1 over 4 h cross squared over mp squared, and the potential energy is of m omega square p square. For minimum energy, here P is mentioned as adjustable parameter. So if you differentiate the expectation value of Hamiltonian with respect to P, you will get 0. If you differentiate a minima or maxima, you will get naturally 0. The first term, if you differentiate 1 over p square, you will get minus 2 p power 3. Then second term, if you differentiate this p squared, you will get 2p, and 2 in this 2 will get cancelled. You will get m omega squared p, which must be equal to 0, or of h cross squared m p power q is equal to m omega squared p. Here you bring this p power 3 to the left hand side. Then this will become p power 4, and bring m omega to the other side, left hand side. Then this will become m squared omega squared. So you will get half h cross squared divided by m squared omega squared, which is equal to p power 4. Then naturally here you have p squared. What is p squared? You take just the square root of this one. If you take square root of this one, you will get 1 over square root of 2 and h cross divided by m omega. So naturally the expectation value of Hamiltonian is, you substitute this p squared here. If you substitute p squared, 1 over p squared, then this will be square root of m omega over h cross, and this will be of m omega squared p squared. P squared is equal to 1 over square root 2 h cross divided by m omega. Now you can cancel some of the thing. You can cancel m here. Here also m you can cancel. And here omega you can cancel with this omega squared, which will become just omega. And you will get this, you can take 1 over 2 here, 1 over 2. That is, this can be written as 1 over 2, then square root of 2 divided by 2, because I am taking this 4 as 2 into 2. So naturally this is 1 over 2 square root of 2 divided by 2 and h cross omega, because this h cross will get cancelled this with square. So naturally here you have h cross omega, h cross omega. Then what about this? Here you have half 1 over 2 divided by this square root of 2. 1 over 2 square root of 2 here, remember. Then you have h cross omega in the numerator. Now what is the value of this one? Is nothing but 1 over square root of 2. So now you take half h cross omega as a common factor, half h cross omega. Then this will be 1 over square root 2 plus 1 over square root 2. 1 over square root 2 into 1 over square root 2 will become 2 times square root 2, which is equal to square root 2. So this will become half h cross omega square root 2. Square root of 2 is 1.414, you know very well. So here it is the minimum ground state energy is h cross of h cross omega. So this multiplicative factor is 1.4. Naturally this is greater than EGS. So we have proved. Thank you very much for watching my video and supporting me continuously. Thank you very much.